Hello, everybody. My name is Chris Winter, and I am the CEO of Reach. Um, really kind of learning as we go by putting these videos out. Last week, the community said they really liked the style of two people chatting. So rather than just me demoing or Dan demoing a feature, I wanted to kind of do a side by side and kind of like a live demo. And so that's what we're doing. Um, so this week, what we're actually doing is we're demoing something very exciting, and what that is a game, a fully decentralized game running in the browser and on Algorand. So that's really special because number one, I believe that I have never seen this done before. I've never seen actually a full decentralized game running on Algorand. Um, and so that's really great. And the other aspect of just the whole running an Algorand thing, because running an Algorand, you'd be able to take advantage of the low transaction costs and the high scalability that some blockchain games will actually need. But before we get our hopes up completely, there are still some features that we're waiting from AlgoSigner, and then also uh, the teal, a couple additions to actually the teal code itself, or not the teal code, the algo nodes. But those are coming, and what I'll do is I'll kick it off to Dan here. Dan is one of our engineers, and he's been the one that's been working on this feature. So I thought it would be best for him to show it off. So Dan, take it away.
Don't mind if I do. Let me go ahead and share my screen
Excellent.
and we'll get started. So this is a game of rock, paper, scissors that two players are going to play on the blockchain through the browser. So over here, one person needs to deploy the contract and the other person needs to attach to that deployed contract. And we're going to call the person who deploys the contract Alice, and the other person we'll call Bob. So Alice is going to set a wager in algos. So the wager for this game is going to be 3 algos, right? So both of them are going to pay in 3 algos, and the winner takes all. So in order to deploy, we're going to sign a bunch of transactions.
Yeah, and so one of the things that you'll see here is that the way that Algorand works is it's different than Ethereum, where with Ethereum you usually send one transaction and it takes care of everything. But what with Algorand to take advantage yeah, of the scaling features and what it can handle, what you're really doing is you're signing multiple transactions and grouping them all together. So what Dan is doing here is he's signing every single transaction that is involved with the initial deploy of the contract. This will be, of course, a much better user experience when this finally launches. One of the features that we're waiting for is an ability to sign multiple transactions at once. So it's one button press rather than all of these. But that's why you're seeing this right now.
And each of these, in order to deploy, you'll notice Alice is sending 0.1 algos to various accounts. That's just how Reach is implemented on Algorand. It uses a few accounts to sort of orchestrate the whole computation. And each of those needs a minimum balance.
Excellent.
Okay. So now the contract is deployed. The Reach program is deployed, and well, first of all, the next step in the program is for Alice to empty up. Alice needs to send in her wager. So that's going to be a set of 3 signatures. And on the third one.
Yeah, so the first group was deploying the contract, getting everything all set up for the game itself.
And now the program has begun, the Reach program. And the first thing the Reach program says is Alice needs to pay 3 algos. Okay. And now Alice is waiting for someone to attach to this contract and join her in the game.
So in this demo, just because this is a demo to show the game working, to find a Bob or for Bob to play with Alice, it's a simple copy and paste. But In a real production version of this game, if somebody built it, you could actually put those variables into a URL, or you could save them in a database if you wanted to list all of the games that are happening. There's really multiple ways you can actually pass this information, so that's Bob can play with Alice. But since this is a proof of concept, a demo showing this working, it's easiest for us to just do a copy and paste.
Mhm. So here we see, Bob, and I've named these accounts in AlgoSigner, Alice and Bob, so that we can tell who's signing what. Bob is sending his 3 algos as the wager as well. So once Alice is monitoring the chain, and once Alice sees that Bob has joined, it will move on to the next step, which is, there it goes. Alice is being asked to choose a hand, and Alice is going to play rock, we'll say.
Good
So
choice,
now,
Alice. Good choice.
thanks. So there will be a set of 3 signatures to send this choice. And what we're sending is actually an encrypted version of her choice, which we will reveal at the end of the program. So Bob is watching for her to make a choice, and Bob is able to see that she's committed to one, but Bob doesn't know which choice she made.
That's a very good point, Dan, is that in blockchain, because of how the blockchain is transparent and you can kind of just look at it and or everybody can see what's happening. Alice doesn't want to put her hand on the actual chain because Bob would say, "Oh, Bob played rock," or Alice played rock, so I'll go ahead and play paper. And so what it does, Alice is actually puts an encrypted version out there. So Bob plays, and let's actually have Bob play scissors because he has no idea what Alice.
Bob doesn't know that Alice played. All right. So let's set 3 signatures to send this data. Oh, my bad. There we go.
Once again, it'll be a much better user experience once we're able to sign multiple transactions at once.
It'll just be 1 signature instead of 3, we hope. Yeah. So now Alice is being prompted to send her actual move. And I typed mine. There we go. And on the chain, it will actually verify that the move Alice is sending now corresponds to the commitment she made earlier. She made a cryptographic commitment to a certain move, and now she's revealing the information that proves that that is what she chose. And after a few seconds, we see that Alice wins because rock beats scissors. And forgot to, if we had remembered to show the balances, we would have seen that since Alice won, her balance went up while Bob's balance went down.
Yes, I can confirm. I did see the numbers beforehand before we started recording, and it did work, which is great. So thank you, Dan. You can stop sharing your screen. So there you have it. Like I said earlier, this is really exciting because I believe this is the first time that I personally have seen a fully decentralized game running Algorand in the browser. I mean, I've seen AlgoNim run on the command line, but this is actually that next step up where regular people that maybe don't know exactly how to use the command line can actually start using things. And the other cool thing is the reason why we use rock, paper, scissors in this is because rock, paper, scissors, the mechanics of rock, paper, scissors is the root of many, many games out there because, rock, paper, scissors, you actually, as you play as a kid, is really how a lot of game mechanics work. So that's why we did that. So Dan, is this code ready? Is that, do you need to do anything more?
No, it's ready. As soon as AlgoSigner is So you mentioned that I'm using a patched version of AlgoSigner so we can point it at our local locally running Algorand DevNet.
Correct.
And as soon as AlgoSigner supports being able to do that, then we won't need to use our patch. Like, yeah, it's ready to go.
Awesome. So I guess what that means is that a developer could come in, start developing with Reach, and so you can learn how to build browser applications, build any type of blockchain application at docs.reach.sh, docs.reach.sh, and you can start developing today. So that means that as soon as the patches come through, the features come through that we need, that means that your code will work day one without having to change your code at all. So this is really exciting, and Algorand and gaming is something that just feels like goes hand in hand because of the low cost per transactions. Dan was showing you there that it was a 0.01 algo per transaction, was it?
Yeah, yeah. Well, less than that for the individual ones. The points.
Yeah, and so it's pretty much it's next to free is really what it is. And when you're playing games and there might be a lot of moves, that's super important. And yeah, so that's everything, I believe. Dan, did we forget anything?
No, I don't think so. Can I just say, I think Reach is a really high level language and it makes it easy to write. It's very, if you look at the source code, the Reach source code is very small for this program.
Right.
And Reach makes, things like this possible, which I've never seen anything this sophisticated on Algorand before.
Where could they find the code for this game?
Good question. The Reach program is the exact same program that's used for the tutorial.
Awesome.
Yeah.
So all they have to do is just go to the tutorial and complete the tutorial, and they'll have this game.
Yes.
Oh,
asterisk the JavaScript side where there are very minor tweaks, which over the next few weeks I'm going to make sure that gets into the tutorial.
okay.
The tutorial goes through how to do this with Ethereum. And now that we have it working on Algorand, we'll update the doc so that it has that too.
Awesome. Well, Dan, thank you so much. Great job and great work. I know there's a lot of people that have been waiting for this and waiting to see this demo. So keep up the good work, and I'm sure I'll talk to you on Slack later today or later this week.
Sounds good. Talk to you later, Chris.
See you later.